Hello, welcome to another trigonometry video from yours truly, Mr. Alexander. Today I'm going to go over how you can use our very good friend, this new guy here, SOHCAHTOA, to figure out unknown angles. So I just taught you in the last video how to find unknown sides. Now we need to find angles. And remember that SOHCAHTOA just really is a way to remember that the sine of an angle is equal to the opposite side divided by the hypotenuse. The cosine of an angle is equal to the adjacent side divided by the hypotenuse. And the tangent of an angle is equal to the opposite side divided by the adjacent side. And we always plug in an angle when we do a trig ratio, but what if we don't know the angle? So let's look at this first example here. So the unknown thing in this here example is that I don't know the measurement of this angle x, but I do know the length of this side, which is the opposite side. I know the length of this side here, which is the hypotenuse, and I don't know the length of the adjacent side. Now, I could use the Pythagorean theorem if I really wanted to find the adjacent side, but I don't really care because I don't need it. Because if you look at SOHCAHTOA and you think to yourself, if I know opposite and hypotenuse, I can use one of these three ratios. It's sine. Sine is the one that uses opposite and hypotenuse. And remember that when you set up a trig equation, you say the sine of the angle, we don't know the angle, but we write sine x equals the opposite side divided by the adjacent side. So 25 over 30, which is a fraction that reduces to 5/6. You could approximate that as a decimal if you so desire, but it doesn't really matter. I'm looking for the angle, and the sine of that angle equals 25 over 30. Now, this isn't a thing that you can solve in your head, but if we could get this x by ourselves, then we'd be in good shape. And so the key to that is we have to use inverse trigonometry. Okay, this word inverse is very important in mathematics. Here's a couple examples up here in the corner. If I square something, right, x to the second power, then the next thing I do is square root it, and those are inverses because they undo each other. The square root and the second power undo each other. What about like x plus 3? Well, the inverse of that would be minus 3 because that undoes plus 3. What about 5 times x? Well, the inverse of that would be divided by 5 because it undoes times 5. In all those cases, you get x by itself, right? And so we got to do the same thing here. We have to use the inverse of a sine. And you might be wondering, well, what is that called? And you don't want to know what it's called? It's actually called inverse sine. Okay, and it looks like this. It's like a sine, but with a little -1 power. It means the inverse of sine. Another way that you might see it come up is it's like a synonym, is arcsine. That these two things mean the same thing. It's two different ways of saying the same thing. And in fact, you'll see them both come up in a moment. So if we want to get x by itself, we can just take the inverse sine because the inverse sine and sine cancel each other out. And so what we'll have here is x by itself. But whatever we do to one side, we have to do to the other. So let's take the inverse sine of both sides. So it turns out that if the sine of x is 25 over 30, then x is going to be equal to the inverse sine of that same fraction, 25 over 30. Okay, and then all we need to do is consult the calculator for the last part. So let's go over here and see our good friend Google Calculator. I'll remind you the first thing you should do when you open Google Calculator is switch it from radian mode to degree mode, because we're only working in degrees in this class. So make sure you always do that. And notice just beneath that button, there's this INV. I'll give you 3 guesses what that stands for. It stands for inverse. And watch what happens when I click that button. See the sine, the cosine, and the tangent all grew a -1 power because they've turned around and become an inverse sine. So if I click on this inverse sine button, it seems to take a couple clicks. It says arcsine, which is the same thing as inverse sine, okay? So I can find the inverse sine of 25 divided by 30, and that is 56.44 degrees. That's just a little bit more than 56 degrees. But we'll round it to 2 decimals. So we'll say it's 56.44 degrees. Yay, we got one. Okay, so let's celebrate that. That's pretty good. Now I'm going to show you another example, pardon me, just down here. My challenge to you is for you to try it. So pause the video right now and see if you can figure out the measurement of this angle, or go back and watch the last one. Okay, but notice where the angle is, what you know. And now I'm going to show you the solution because you've had a chance to pause it. So we know the opposite side, we know the adjacent side, and we don't know the hypotenuse. Doesn't matter. We could find it with the Pythagorean theorem, but we don't need to because we can use tangent to do this, because tangent is opposite over hypotenuse. So we'll just say the tangent of x is equal to the opposite side, that's in our case 17.8, divided by the hypotenuse side, 10.4. And now, just like we did before, if we want to get that x by itself, let's just use the inverse tangent, because inverse tangent undoes tangent, but whatever we do to one side, we have to do to the other. So we'll use the inverse tangent on both sides, and so I know that x is equal to the inverse tangent of 17.8 over 10.4, right? So if the tangent of that angle is equal to 17.8 over 10.4, then that angle is going to be the inverse tangent of that same fraction. And so then we just use our calculator, and I believe, let's see, let's just do it. I'll clear this out. I'll find the inverse tangent. See, it says arctan. 17.8 divided by 10.4, 59.70 degrees if we round to 2 decimal places. So hopefully that's what you got. And if you didn't, you can go back and figure out what you did wrong. So stay tuned for the next video, the next series of videos, when we get into the laws of sines and cosines. That'll be fun. In the meantime, you should do the Desmos activities that are posted in Schoology if you haven't had a chance to do them yet. Take care.